Let's review the rules for nth roots. First of all, if you have, in this example, nth root rules. In the first part, if you have the nth root of base a raised to the nth power, that is simply going to be equal to the base a when the root index n is greater than or equal to 3, and if it's odd. Oh my goodness, let's see. So the nth root of a to the nth power just has a direct cancellation of the nth root and the nth power and leaves the remaining value a whenever the index in the hook n is a number equal to 3 or larger. It's going to be a whole number equal to 3 or larger, and it happens to be odd. So when you have an odd index, the nth power under the radical sign cancels with the nth root. Okay, what's the second part of this rule? The nth root of a to the n power will be equal to, okay, now again we have a cancellation, but instead of the answer being a, like it was in the first case, we get the absolute value of a. When does that happen? When do we get the absolute value instead of just the value a? That happens when the index n is 2 or larger and even. So basically what we have here is that the nth power under the radical sign cancels with the nth root and leaves the base a when we have an odd index, but it leaves the absolute value of a when we have an even index in the hook. And the reason for that is we want to make sure that the base itself, the solution of an nth root, it has to be non-negative when you have an even index. That's the reason for the rule. Now, you can memorize the rule, or you can remember what I just said about why we use this rule. Now, let's see the application, because this is really abstract. Let's do some examples. The cube root, the third root of base 27. Well, 27 can be written as 3 to the third power. So this is asking for the third root of 3 to the third power. So I see that the third root and the third power match each other. They're going to cancel. Now the question is, do I slap absolute value bars on the remaining value 3, the base value 3? And the answer is no, I don't need to, because the index was odd. We never worry about absolute values when we're taking an odd indexed root. So we just go ahead and leave it as positive 3. Let's do the next example, the cube root of negative 27. Okay, cube root of negative 27 can be written as the cube root of base negative 3 in parentheses raised to the third power. It's true that negative 3 to the third power gives you negative 27, so it's legal to write it this way. Now we get a cancellation of the third power and the third index, the third root, and now that leaves a negative 3. Now the question is, do we slap absolute value bars on that negative 3 to make it positive, or should we just leave it as negative 3? And the answer is just leave it as negative 3. And the reason is because we have an odd index root. An odd index root never worries about positive or negative answer. It just is what it is, so you don't have to sweat it. You only sweat it when you're taking even indexed roots, like this example. The fourth root of base number 16. Well, that can be written, 16 can be written as 2 to the fourth power. So now we have a matchup between the power under the radical sign and the index in the hook. So we can cancel the exponent 4 with the index 4. Now that leaves us the base 2. The question is, do we just write 2 or do we put absolute values on it? Well, you saw that the index here was the number 4, and 4 is an even number. That's the only time the alarm goes off in your head. You say, I've got to be careful. I've got to slap absolute value bars on my answer. So the absolute value of 2. Well, fortunately, the absolute value of 2 is the same as 2, so our answer is simply 2. So you don't have to show that step, but in your mind you're going, I did take the absolute value of that to be careful. Okay, let's do it again. The fourth root of negative 2 in parentheses raised to the fourth power. Okay, now this question is given to us with a negative base under the radical. This is how the question starts. It's different than the one right above it, the fourth root of 16. This one was given to us as the radicand, the stuff under the radical sign, being base negative 2 in parentheses raised to the power 4. So what I notice is that the power 4 and the index 4 match each other, so I'm going to cancel them out, and that leaves a negative 2. Do I just write negative 2? No, I don't, because I had an even index root, which means I always slap the absolute value bars on my answer. The absolute value of negative 2. So just like the problem above, because it was an even index root, I slapped absolute value bars on it. I did it here too. And in this problem, it actually makes a difference because the absolute value of negative 2 is different than negative 2. It's equal to positive 2. All right, so each one of these cases should be approached individually. Don't think about the problem that came before it. Just think about the problem that's before you. And the main thing to remember is whenever you have an even index root, you have to make sure that your answer is non-negative.